Hello. Today I'll be working on example 17. It has two questions. So let's take a look at the first one. So we want to find the open intervals on which the function is increasing or decreasing and locating all the relative extrema. And our function is right here. So basically we're going to want to start by finding the critical points. And we can do that by taking the derivative of this function and setting that equal to 0. So let's start. We're going to have to use the quotient rule for this. Okay, so we found our first derivative there, and we're going to set it equal to 0. So if we continue on, we'll get our first critical point, which would be x equals -6. So basically from there, I just used the quotient rule and got our first critical point. We can also set the function equal to d and e, basically, because we want to find where it does not exist. So we can set our x cubed equal to 0 there, because that would make the function not work. And we found our second critical point at x equals 0. So our critical points are there we go, 0 and 6. From there, we're going to make our sign chart because we want to find our open intervals. So from here, we're basically going to want to plug in some values to understand where it's positive or negative. So I'm going to take -7, -2, and 1, and plug those in back to our function to see whether or not it's positive or negative. That's less than 0, so we know this is going to be negative. That's positive, so do that. And finally, we're going to plug in 1. And that's going to be smaller than 0, so it's going to be negative from 0 on. All right, so we've made our sign chart by plugging in some values, and from there we can tell where it's decreasing and increasing. And it looks like it's increasing from -6 to 0. and it's decreasing. From negative infinity to negative 6. And also 0 to infinity. We're going to have an absolute minimum at x equals negative 6, because we can see here it's decreasing to increasing, so we know that's going to be a minimum. And 0 right here is actually an asymptote, so it won't be a minimum or a maximum. We can write asymptote here. We can just say x equals 0 there. All right, so that's basically problem 1 of example 17. We've found our open intervals and our absolute minimum. By doing that, we did that because we found the derivative instead equal to 0 and dne to get our critical points. We made our sign chart, and yep, just found our intervals and our absolute minimum. All right, I'm going to move on to the second part, problem number 2. This is going to be a true or false, and it's asking or stating the problem or the product of two increasing functions is increasing. Now, to prove that this is false, all we need to do is find one example where the rule doesn't apply, because if it's not always true, it's false. So we can just write some functions here. I'll call it f of x and g of x. And those will be our functions, and we can call h of x the product of these two, and that will be 2 over x cubed. Now from here we're going to want to make some more sign charts, and to do that we're going to need to take the derivative of all of these. So the derivative of f of x should be 1 over x cubed. And we're just going to want to find where it does not exist. So we'll just set our denominator equal to 0, giving us 0. And we know it's going to be positive on both sides. If we plug in a -1 or a 1, it'll both give us a positive number. So we know this is, for sure, increasing. So let's go and find the derivative of g of x. That'll be once again, we're going to find where it does not exist. And we'll just set our x cubed equal to 0 once again. And the sign chart will be very similar. And it will be, once again, increasing. All right, finally, we're going to be taking the derivative of h of x, our product function, and figure out if it's increasing or decreasing. And we're just going to want to figure out where it doesn't exist again. So just set that denominator equal to 0. Once again, being 0. Now, on the first half here, it would be positive. Plugging in -1 would give us a positive answer. But plugging in a positive 1, we would get a negative answer, showing that this is actually decreasing. So we have increasing, increasing, decreasing. So we would know that this would be false, because we have found an exception to the rule. And that's it. Once again, here's our open intervals and absolute minimum for number 1. And we found an example for number 2 where the statement would be false. I did record this on my iPhone, so I apologize if the video is shaky, but thank you for watching.